Hey students, this is lesson 622, point slope form. What you're going to do is learn how to write and graph linear equations using a different form of a line called the point slope form of a line. In a lot of situations, it's a lot easier to graph it this way as long as you know the formula for point slope. Go ahead and quick do this review. It's reviewing the slope-intercept form. All right, so this problem will help us introduce you to point slope form. One thing you'd have to do, this says write the slope of the line in slope-intercept form, and I'm going to go through that. Now, you can see that the balloon is descending at a constant rate, so it's a linear equation. And what we would need to do is find the equation of the line. In slope-intercept form, we would first need to use two of these points to find the slope, like maybe those two. And then we would have to find the y-intercept. One way we could do that is just estimate where it touches the y-axis there. That's not real accurate, though. There may be a better way. Or we could just compute what the y-intercept is once we know what the slope is, the way we learned in the last one. So we have two points here, 5, 6, 40, and 15, 6, 20. To find the slope, we would use this formula. The slope is y1. Well, we have to subtract two y coordinates, and then we have to subtract two x coordinates, and then divide those. And in this case, we can substitute for the slope. We can do 640 minus 620 divided by 5 minus 15. And that's equal to 20 over 10, which is negative 2. 20 over negative 10, which is negative 2. So we can see that the balloon is descending at a rate of 2 feet per second or minute, whatever it is on there. Now, just think about the slope formula for a second. If we had an equation in slope-intercept form, what we have right here is the slope. We have a y-intercept, and then we have x and y variable in there. If you look closely at this formula, we have an x and a y variable here. And just think if I took one of the points I have from this balloon problem and put them in here for x and y. So I'll just take this first one here. So y minus 640, because that's the y value, and x minus 5, like that. Then if I rearrange this formula, so m is equal to y minus 640 divided by x minus 5. If that's true, then in this fact family, we can also say that m, the slope, times x minus 5 is equal to y minus 640. And if I rearrange that, and I can substitute my slope value for this problem. We just computed that that's negative 2. Then if I just rearrange that, just swap the expressions around the equal sign, I get this. Y minus 640 is equal to negative 2 times quantity x minus 5. Well, that's a legitimate equation. It looks a little different than our slope-intercept form, but it can be used for an equation. And notice where I got the values for that. This 640 is just this y value from one of the points. I could have just as well taken this 620 as that y value. And then this 5 here is the x value. So in general, what we can do is just subtract some y coordinate, and that's what my y sub 1 is, from y. And then put in our slope, and then subtract some x coordinate. That's what my x sub 1 is here. And I have an equation. And that equation is called the point slope form of the line. And the reason it's called point slope is because this x sub 1, y sub 1 is just any point on the line. So that's a point. And then the m is a slope just like slope. Intercept form. So that's a quick way when you're given information like this, lots of points. It's a quick way to find an equation. So here it is, point slope form of a linear equation. X sub 1, y sub 1 just represents any point on the line. And m represents the slope. So how would we go about using that? So I'm going to write this down again, and you should kind of get used to this, but we have to have this formula in mind. So a line passes through the point 1, negative 4, and has a slope of 3. What is an equation of a line in point slope form? So now remember, x sub 1, y sub 1 is any point. So just take those values and substitute them for x sub 1 and y sub 1. And m is the slope. So any point and the slope. So in this problem, we are given a point. Here's my x sub 1. Here's my y sub 1. And the slope m. So I'm going to put 3 for m. Notice I put it there. I'm going to do y minus my y value. My y value is negative 4. So y minus my y value is equal to 3 times the quantity x minus my x value, which is 1. And I now have an equation. The only thing I might do is simplify this. Y minus negative 4 is the same as y plus 4. All right? Go ahead, you try it here. Check back with your answers. All right, how'd you do? The only tricky part is when you have a negative, you'll be subtracting a negative because in the formula there's a minus. So whatever the y value is, you have to subtract that. Whatever the x value is, you have to subtract that. All right. This can also be handy for graphing. If you are given an equation in point slope form, then you can get 1 point and the slope from that equation. So I'm just going to write down underneath this what the form actually is, so we can use that to get our values. Okay, so the first thing we have is y minus y sub 1. So our point is x sub 1, y sub 1. And my y sub 1 here, what am I subtracting there? Well, I'm actually subtracting negative 3 because subtracting negative 3 is the same as adding 3. So my y sub 1 is negative 3. My slope right here is negative 2, so I'll just write that down. I'm going to use that. Slope is negative 2. And my x value, what am I subtracting from x? I'm subtracting 2. So my x value is 2. Now I'm going to put that point right on the graph, the point 2, negative 3. That's right there. And then I'm going to use my slope to help me get some other values. And you can do this with a table or just do it on the graph. So I have a point at 2, negative 3. Now my slope tells me that every time my x value goes up by 1, my y value goes down by 3. That's what a slope of, or goes down by 2. That's what a slope of negative 2 means. So I can keep subtracting 2 from this y value here. Negative 3 minus 2 is negative 5, negative 7, negative 9, and so on. You could also just do that on your graph. Every time you go over 1, you would be 2 lower. So I could just go down 2 each time I go over 1, and that would look like this. Or if you just graph the points that I have written in that table, you'd see you'd have the same points. Then all you have to do is draw a line through those points. And it's fairly quick to make a graph. All right, go ahead, you try that, and you can check back with your answers. All right, I'll help you graph this here and talk about it a little bit. So we have a point at 4, negative 7. That'd be right down here. Okay, and then when you have a slope of negative 4/5, that means, and I can put this in a table also. So we know there's a point at 4, -7. We could either think of this as -4/5 or as 4 divided by -5, any way you want. The one that's going to help us get some more points that'll fit on this graph is if we think of it as a +4 divided by -5. So that means if I go up 4 on x, I go up 4 on y, so that means -7 plus 4 is -3. My x value goes down by 5, which is -1. And I can do that one more time. I can go -6, that would be adding 5 to the x value, or subtracting 5 from the x value, and then we have to add 4 to the y value, which would give us 1. So -1, -3, and then -6, +1. That's right there. And we just draw a line through those points. And that's our graph. All right, using 2 points to write an equation. All right, this is just a little bit different. If you're given 2 points, you can use point slope form just by using one of those points and then using the 2 points to find the slope. So the first thing you're going to do is use the 2 points to find the slope. So we're going to take these 2 points are marked down here. We're going to subtract the 2 y values. And that would be like 4 minus -3. And then subtract the 2 x values. That would be 1 minus -2 to get our slope. And that would equal 7/3. So, and just checking that quick here, that means we're going up 7 for every 3 we go over. If we divided that out, we would get 2.3 repeating, and since it's a repeating 3, I'm just going to leave it as a fraction. I think that's a cleaner way to do this. So now we need to, it says use this point. You could actually use the other point, but we're going to substitute those values in. My y sub 1 is -3, and my x sub 1 is -2, and my slope is 7/3. And then I'll just simplify that. Subtracting a negative is the same as adding. And so I get this equation in point slope. All right. Okay, one last thing we're going to do is learn how to write an equation in point slope form, given some information. And we're going to actually use point slope form to get the equation, and then we're going to change it to slope intercept form just by simplifying the point slope form, which isn't too hard. All right, so let's start with our information here and the fact that we can write an equation in point slope form. So here's my point slope form. Now, first thing we want to do is make sure we have the slope, and the slope is just the change in y divided by the change in x. Or if I subtract any 2 y values, so 210 minus 130 is 80, then I subtract the corresponding x values, which is 5. Then I'm going to divide 80 by 5, and that's 16. And what that means is Julio is earning $16 per hour. All right? And one of these questions asks, what does that slope mean? And it means that's his hourly wage. All right, now, for my x and y value, I'm just going to pick one x and y value from the equation. Hours worked are x, wages are y. So I'm going to do y minus 130, so I'm substituting in the y value. And my slope is 16, and then I'm going to substitute 5 for my x value, and I now have my equation. Now all I have to do is simplify that equation. I'm going to use the distributive property. Multiply that out, then I'm just going to add 130 to both sides. And I get y equals 16x plus 50. My y-intercept is 50, and what that tells me is Julio gets $50 plus $16 an hour for his wages. All right, that's it. We'll use that in class. See you tomorrow.